Here's another example where we are solving for x, and we have a little bit more going on than we did last time. So we don't have just sine of 2x equal to a number, but we have this whole convoluted equation. And it looks a little bit intimidating, but one thing we just need to keep in mind for this type of equation is we want to isolate the sign. In this case, it's the sine of 2x. We want to just get it all by itself. So I'm going to start to just manipulate this equation by adding the square root of 3 to both sides. And then I'm going to divide out by 2. Now this is looking something a little bit more manageable. Sine of 2x equals the square root of 3 over 2. This looks like a special unit circle ratio, so I'm feeling pretty good about this. And now I'm going to carry over and do what I had done before, and I'm going to use a u substitution. So I'm going to say let u equal 2x, and I'll continue sine of u equals root 3 over 2, and if I know my unit circle, I know that u could equal either pi over 3 or 2 pi over 3. Oh, that's a 3. Okay, and next up what I need to do is I need to pull out or put my 2x back in, and I'm going to write this as 2x could equal pi over 3 or 2 pi over 3. If I divide everything by 2, or let's say multiply by 1/2, multiply by 1/2, multiply by 1/2, I'm going to get pi over 6, and I'm going to get pi over 3 as two possibilities. But actually, let's leave that in terms of pi over 6 for now, and then we could reduce later. So let's call that a 2 pi over 6. Okay, so these are kind of like my base solutions, and now I want to start to add or subtract periods. My period of this graph, let's move over to here. I'm going to add period, which is equal to, in this case, I have a b value of 2, so this is going to be a period of pi, or I'll say 6 pi over 6. And let's keep thinking in terms of pi over 6. My upper bound is 3 pi, which is the same thing as 18 pi over 6. And so I'll say that x can equal, here's my two base solutions, pi over 6 and 2 pi over 6. Now let's start to add 6 pi over 6 until I reach my limit. So this is going to be 7 pi over 6. Another 6 pi over 6 will be 13 pi over 6. Another 6 pi over 6 would be 19 pi over 6. That's too high. So I'm going to stop there. Then over here I've got to add a 6 pi over 6. So that's going to be an 8 pi over 6. Another one will be 14 pi over 6. It's 14 pi over 6. Another one would be 20 pi over 6. That's too high, so I'm stopping there. So my final solution then would be x equals pi over 6, 7 pi over 6, 13 pi over 6. That's not a 6. 13 pi over 6, pi over 3. Now I'll reduce. 4 pi over 3, and 7 pi over 3. Now you'll notice too that sometimes I'm writing my solutions kind of in this stacked bracket form, or sometimes I'll write them all lined out. There's really no right or wrong way. I like to sometimes just visualize it in this array, or really it's just kind of how I'm feeling at the moment. They're both acceptable ways to display your answers. Okay, why don't you try this problem right here. Give this one a shot. I have a little bit of a hint for you. When you solve this one, you might see an unfamiliar special unit circle ratio, but maybe it'll look familiar if you rationalize your fractions. That's my hint to you. Pause the video, give this problem a shot, and see how it goes. Okay, here is my solution. Check out all of the work, and then the final answer is this: these 6 possible solutions. So hopefully that one went okay.